Last video, we talked about the different types of greenhouse gases and their common sources, as well as how they contribute to global warming and climate change. In this video, we're going to delve deeper into the water sector's role, which we touched upon briefly last time. The significance of the water sector's contributions to global warming can sometimes be underestimated. It tends to be lumped together with other industries, leading to misrepresentation, such as associating wastewater treatment plants with landfill emissions. However, it is essential to acknowledge that water-related processes, especially wastewater treatment facilities, constitute a distinct and noteworthy source of greenhouse gas emissions. In this discussion, we will begin by addressing the water sector in its entirety, but our subsequent focus will be primarily on wastewater treatment facilities. Let's explore how the water sector functions. There are four main components. We first purify fresh water in water treatment plants, distribute it for use through the water network, collect the wastewater through the sewer network, and treat it before discharge at wastewater treatment plants. We'll focus on the first two parts first. In Canada, we are privileged to have access to some of the world's largest renewable supplies of water. We have access to over 20% of the world's surface freshwater and 7% of the world's renewable water flow. Different municipalities source their freshwater based on environmental factors, like proximity to water bodies, rainfall patterns, and aquifer recharge rates. For example, Toronto and Vancouver rely on a combination of surface water from lakes and rivers for their water supply, specifically Lake Superior, which is the world's largest freshwater lake by surface area. Quebec holds 3% of Earth's renewable freshwater reserves, and nearly 40% of all this water is concentrated in the St. Lawrence River watershed, which drains rainfall and melted snow into streams. After collection, fresh water is pumped to treatment plants for purification. Just because it's called freshwater doesn't mean it's actually clean yet. Various procedures such as coagulation, flocculation, sedimentation, and filtration ensure water meets quality standards based on its intended use. The purified water is then stored in reservoirs and distributed through a network of pipes to consumers. That's where it reaches faucets, sprinklers, and supports energy generation in hydroelectric and thermal power plants. Toronto alone has 6,100 kilometers of pipes in its distribution system. That's greater than the distance between Toronto and Paris. So, you might be wondering, where do greenhouse gases come from in this context? Remember our discussion regarding Scope 1, 2, and 3 emissions from the last video? Well, within the processes and systems of water facilities, here's how emissions are classified. Direct, or Scope 1 emissions, are released into the atmosphere as a direct result of the processes or activities owned or controlled by water corporations. An example of this is the water treatment process. Indirect, or Scope 2 emissions, are released off-site or by another entity due to actions or activities associated with water corporations. An example of this is the use of electricity generated from the burning of fossil fuels in order to run plant processes. While water corporations are not always required to report Scope 3 emissions, which come from indirect sources that are typically outside the direct control of water corporations, they're still important to consider. They can come from the production and transportation of chemicals and materials used in treatment, for instance. Cumulatively, we can also call all of these life cycle emissions, since they contribute to the greenhouse gas profile of water facilities from the time that they are created and all throughout the time that they run. A study conducted by researchers at the University of Toronto in 2007 found that water treatment facility emissions for Canada totaled 66,796 tons, or around 0.07 megatons of carbon dioxide equivalent per year. 90% of this total came from process operations, which includes treated water pumping, raw water pumping, filtration, and backwash water pumping. The other 10% of emissions comes indirectly from chemical manufacturing and transportation. When we think about water, we often focus on the water we drink or use in our daily activities like showering and flushing toilets. However, there's another crucial aspect that deserves our attention. What happens to water after we've used it? This is where a significant factor comes into play in the context of climate change. Wastewater. Wastewater refers to water that has been discarded because of human activities. It contains a diverse range of contaminants and can pose risks to the environment and human health if not properly treated before being discharged or reused. Wastewater treatment has been crucial to controlling and monitoring disease and virus outbreaks, especially in the last 5 years. One notable example is coronavirus, which has regularly been detected in wastewater samples. Monitoring wastewater can help provide valuable insights into the progression of pandemics. However, it also highlights the potential risk of secondary transmission of viruses through waterborne and wastewater routes if proper sanitization measures are not implemented. Let's break down what exactly happens to municipal wastewater, which is a collection of household, commercial, and non-hazardous industrial wastewater. If left untreated, wastewater finds its way into rivers, lakes, estuaries, and seas. To prevent this, wastewater is either treated on-site in latrines or septic tanks, or it is collected and transported through sewers to a centralized treatment plant. Once at the treatment plant, it undergoes a series of processes, which can be physical, chemical, and biological, and have energy-intensive expenditures, as well as greenhouse gas emission profiles. Similar to water treatment facilities, greenhouse gas emissions in wastewater facilities can be both direct and indirect. Scope 1 emissions originate from biological activity in processes that treat wastewater, which directly release carbon dioxide, methane, and nitrous oxide into the atmosphere. Unclean water contains bacteria that metabolizes organic materials and contaminants and converts it into greenhouse gases. Scope 2 emissions come indirectly from the generation of fossil fuel-based purchased electricity, heat, or steam that is consumed in wastewater treatment plants, owned or controlled equipment and operations. For instance, energy usage for pumping during transmission, aeration, and mixing processes qualify as Scope 2 emissions. The amount of indirect emissions will typically vary based on the precise energy source and the size of the facility. Finally, Scope 3 emissions arise indirectly from materials and consumables used for the treatment of wastewater, like the manufacturing and transportation of chemicals used in the treatment processes. Let's quantify these emissions. In 2006, a study conducted by researchers at the University of Toronto calculated that the total carbon dioxide equivalent emissions from the municipal wastewater sector across Canada for that year were approximately 1.05 megatons. 33% of this total can be attributed to upstream emissions, which come from off-site production and transmission of fuels that are used on plants. As mentioned before, it's necessary to consider these emissions as fundamentally a part of the wastewater sector when employing the life cycle approach. 56% of wastewater emissions come from processes, essentially the direct sources discussed previously. The remaining 11% of emissions come from facility heat, which is on-site fuel used for heating and electricity. However, this emissions profile of 1.05 megatons is only the tip of the iceberg. This number was projected to increase over the next 20 years, and it has, significantly. A study conducted in February of this year that performed emissions measurements at 63 wastewater treatment plants in the United States found that they emit over 5.3 megatons of carbon dioxide equivalent, 5 times greater than the aforementioned study reported. For a government-reported figure, the EPA finds that as of 2019, total greenhouse gas emissions from the wastewater sector amount to 44.8 megatons of carbon dioxide equivalent. Similar trends are likely applicable to wastewater treatment plants in Canada as well, and thus we must remain vigilant. Now that we understand the processes and greenhouse gas contributions of freshwater and wastewater treatment facilities, an important question arises: which has the greater impact? Going back to the 2 Canadian studies we looked at, we find that the amount of CO2 equivalent emissions per year for wastewater utilities is 15 times greater than that of water utilities. Let's put things into perspective. Each liter of gasoline burned while driving your car releases approximately 2.3 kilograms of carbon dioxide equivalent. Now, consider the greenhouse gas emissions generated by wastewater utilities over a year based on the findings of the 2023 US study. It's equivalent to the emissions from consuming about 2,304 liters of fuel. To give you an idea, the average fuel efficiency of light-duty vehicles in Canada is approximately 11.24 kilometers per liter. With that amount of fuel, you could cover a distance of approximately 25,897 kilometers. The Earth's circumference is roughly 40,075 kilometers, so it's like traveling more than halfway around the world. Addressing wastewater emissions becomes even more crucial in the broader context of water-related climate change. In the upcoming videos, we will delve into how wastewater specifically contributes to different types of greenhouse gases. In conclusion, it is evident that the water sector, with a specific focus on wastewater treatment, qualifies as a substantial and distinctive contributor to greenhouse gas emissions in Canada. Throughout this video, we have gained an understanding of the operations of freshwater and wastewater utilities, identified the sources of both direct and indirect emissions within these systems, and quantified their annual greenhouse gas emissions. It is crucial that we recognize the significant role of the water sector in contributing to the overall greenhouse gas emissions and take proactive steps to minimize its environmental footprint. Together, we can work towards a greener and more environmentally responsible water sector in Canada and beyond.